So we're going to do some problems here. So this is number 48 out of the book, so if for any reason things aren't focused well, at least you can start with that. So looking at this, we have a current source that comes up, and then it splits into two branches and comes back around. And so the idea is how much current, and then within each branch this way, now it splits again. So how much current is flowing? This is an ideal case for current divider. I see that these two are in parallel because if I look at the ends of these resistors, they're in the same node. I go on the other side, it's the same node. So not only do they look like they're in parallel, but they are in parallel. So those are in parallel and those are in parallel. So my process that I'm thinking is, if I can get equivalent resistances for these, then I just have a perfect setup for current divider. I'll do that and then go back to the smaller pieces. All right, so the first thing I'm going to do is find that 6 in parallel with 12 is 4 ohms, and 6 in parallel with 3 is 2 ohms. So now redraw the circuit. I'm a big advocate of redraw the circuit every time. So here I have 4, I have the current in the middle, and I have 2. So you can see what I've done here is that I have, instead of writing the 4 and the 2 up here, I've just slid them around. And I can do that because a longer wire is still a node, a shorter wire is still a node. So you can rotate things around, it's easier to see. And then if I want to even make it a little bit easier, we want to make it more obvious yet, I can draw it this way. So again, either way, clearly a current divider. I've got current coming out and dividing between two branches. So perfect for current division. So here, if I want to know the current through the 4 ohm resistor, that's just going to be the other resistor, 2, divided by the sum times the source current. So 1/3 times 4, 4/3 amps. So I know that I2 ohm, well, I can do that one of two ways. I can do a current divider again, so 4 divided by 6, 8/3. Or I could have done KCL, right? I could have done KCL at this node here. If I already know the current through the 4 ohm here, then I could just do KCL. And let's just double check that that works. So the current going out is going to be 4/3, and then another 8/3, and current coming in is negative, and then equals 0. So far so good. Okay, so now that I've got that, I need to go back to my original circuit. And here I'm going to work out one side, and I'll let you guys do the second side. So looking at this, here, I know I've got 4 amps coming up, and then coming through this 4 ohm resistor, I have 4/3 amps. So now I'm just going to handle just that one side. I'm going to take that piece of the circuit separate. So here I'm going to look at this one. I know that there is 4/3 amps flowing in that direction, 12 and 6. And then it's flowing back out again. So if I want to know how much is flowing in each branch, again, perfect setup for current divider. So this is I1, this is I2. So I1 is equal to the other, so I'm looking for I1 through here, so the other resistor is in the numerator, so 6 divided by 18. So 6 divided by 18 times 4/3 is 4/9. And normally we don't work in fractions, but because we're going to add these up at the end in order to avoid round-off error. So I2 will be 12 over 18, 4/3. So this makes sense then. Another way it makes sense, this resistor is 12 is twice as big as 6, so I expect half the current. Is that true? 4/9 is in fact half of 8/9. So this is just a really fast way to solve this circuit. So anytime that you see resistors in parallel, and you're looking at current going through them, you will know the current through each branch very quickly. Okay, let's look at, I think that's all I'm going to do on dividers. Let's look now at source transformation. Okay, so here's a case where, oh, it's trying to focus, I'm sorry. Here's the voltage we're trying to find right here across the 4 ohm resistor. This looks really complicated. However, if we think about this, there are actually a lot of parallel pieces. Look between these two nodes. This current source and this resistor, those are in parallel. These two in parallel, those two in parallel, those two in parallel. So in every corner, we have a parallel set. And then if we write in some nodes, let's do this, some colors on. Here's A, B, C, D. If we look at that, in between each set of nodes is parallel, but then it's series connected from A to D, and from A to B, and B to C. So it's like there are these pairs of parallel pieces that are connected in series going around the circuit. So this is a case that kind of screams out for source transformation, because since the overall sort of connection is series, if I can make this series instead, so looking over here, if I could convert this to this, then I'm just going to have a big set of series going all the way around. So let's look at that. So the first thing we'll do, let's just pick one to start with. So let's start with A and D. And I'm going to write it this way. I'm going to kind of stretch it out a little bit. Here's A and D. Let's make sure that that makes sense. They're connected at A and connected at D. I just sort of made them look more parallel to make sure that that makes sense. Okay, so now I'm going to take this and I'm going to convert that to series. So I just am going to have in between these a series set of a voltage source and a resistor. So essentially what I've done is I've taken this and sort of stretched the terminals up to the top, and that's fine. So again, just moving wires around doesn't change the nodes. Okay, so looking at this then, you know that this is going to convert to, I think I want to put the resistor on top. It does not matter. It's just to keep kind of consistent with how I've drawn other things. So here's A and D. Now, we have to pay attention to the polarity. This current is going down, so this voltage source needs to be going down. Okay? Or let me write it another way. If the current's pointing in this direction, that's the direction of the gain on a voltage. So this is a minus, and this is a plus. And I'm waiting for that whiteout to dry. There's a 4 ohm resistor right here in the middle. So how much is V equal to? V is equal to IR, 2.5 times 4, 10 volts. So it's 10 volts in this direction. If I wanted to flip it, I could just call it negative 10. Okay, so that's one. I can do that going all around from B to C.